Okay, so our second problem is y equals cosine of 2 theta. Okay, so this one's going to be we're going to encounter a different problem than we did in the first one. So once again, we take a look at the number in front. The absolute value of the number in front gives us the amplitude. There's no number there, so the amplitude is just 1. Okay, period. Period is going to be 2 pi over b. So this is the first time we're seeing this. That number in front of theta is b. So 2 is b. So my period is going to be 2 pi over 2, or just pi. Phase shift, I'd rather call it horizontal shift. Your notes should say horizontal shift. There is none. Like I said, we'll see this in the third example here. And then the vertical shift, there is none. There's no number being added on at the end. So the only thing here is that the period changes. So this means this graph is going to go through one cycle in pi as opposed to 2 pi for a regular cosine. So this curve is going to go actually like kind of faster than normal. Okay, so same rules apply. What we're going to do is we're going to take the period, divide it by 4, and that's what we count by on the x-axis. All right, so pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and 4 pi over 4, which is pi. And like I said, I like to go negative. You can keep going in the positive direction. I will usually ask you to graph 2 complete cycles, so this almost ensures that you get that second cycle. All right, and there's no change in the amplitude, so let's just kind of take our space with this. No need to jumble it, scrunch it all up in that small segment there. All right, so the only thing that changes is the period. So we're going to start up high. Cosine starts up high. It starts up at 0, 1. We get that from the unit circle values. All right, and then the pattern for cosine, it's going to follow that up-down pattern. It's just going to look a little differently than our original because we've shifted the period. But it's still going to start at 0, 1, except we're going to start going down at pi over 4. Pi over 4 is going to turn into 0. And then this pi over 2 is going to become negative 1. 3 pi over 4 goes to 0, and then pi goes to positive 1. So it's the same pattern as the original. Everything just is like a little bit squished. That's what a change in period can do. It can also expand it out. All right, so that's one cycle, and we'll continue it on the other side for the second cycle. We just continue that pattern. And remember, cosine is symmetric about the y-axis. It's an even function. If that helps. If that doesn't help, then don't think about it like that. But the symmetry, this pattern, just continues on the other side. Looks good. Cool. So this is y equals cosine of 2 theta. To give you an idea what that looks like compared to the original graph looks something like this. See, it takes a lot longer to get down there to negative 1. So remember that original graph, we graphed the pi over 2's instead of the pi over 4's. So it takes that curve a little bit longer to get there. So you can see there's a big difference in what these two graphs look like, what that change in period does to a function. In this case, it gets closer together than the original.